Savyajaya Vinodai, and a warm welcome to all the guests present here. We commence today's program by introducing our esteemed in the ceremonial lighting of the land at the sacred altar of Ma Saraswati, the deity of knowledge, wisdom, and learning. Dr. Kumud Ranjan, President of Education Society, Advocate Shri Ulhasji Aurangabadkar, sir. Vice President, Education Society, Shri Deepakji Dudhane, Chairman CDC of our college, Professor Vilasji Deshpande, Secretary, Education Society, Shri Sureshji, sir. Principal of our college, MPD Memorial Science College, Nagpur, Dr. Akhilesh Peshwe, sir. All the esteemed members of the management, invited guests, faculty members, and my dear students. On behalf of Education Societies, MPD Memorial Science College, I feel privileged to extend a warm welcome to all present here for today's Golden Jubilee Lecture Series. Today's interface is a special session on Semiconductor Technology, Opportunities and Challenges for Bharat, a theme that is crucial for our nation's journey towards technological self-reliance and innovation-driven growth. This will help our students and faculty to understand how global developments in semiconductor research connect with India's journey towards self-reliance, industry growth, and high-skilled employment. I humbly request our esteemed principal, Dr. Akhilesh Peshwe, sir, to deliver his opening remarks.
So much. With tributes to Goddess Saraswati and homage to the founding fathers of this institution on this golden occasion, I begin. It is my proud privilege to welcome one of the most renowned and highly acclaimed scientists in the field of semiconductor technology, Dr. Kumud Ranjan, sir. I also extend my heartfelt respect to our mentor and constant source of inspiration, Honorable President of Dharampet Education Society and President of today's function, Advocate Ulhasji Aurangabadkar. A warm welcome to Honorable President of CDC, eminent scholar and scientist from VNIT, Professor Vilasji Deshpande. Honorable Secretary and former NIT top brass, Shri Sureshji, Honorable Vice President Shri Deepakji Dudhane, Treasurer of DSC Anandji Apte, and all the esteemed officials and executive members of Dharampet Education Society and the CDC. I also acknowledge the presence of media representatives and my dear colleagues and beloved students. Your precious presence has truly made this event golden. Since its inception, the institution has contributed to society in countless ways. Over more than 50 years, it has groomed and shaped renowned military officials, insightful politicians, policymakers, social scientists, award winners, and social workers of the highest acclaim. Our alumni achievements span from the Padma Shri Award to the Gallant Yuddha Seva Medal, and from important ministers to honorable chief ministers, and from celebrated teachers to the pioneering scientists. We are proud to be a grade A institution for nearly a decade, offering one of the most evolved curricula. Our programs are so well developed that we earned a perfect 4.0 in criteria 1, that is curriculum development and planning of NAC. The Jubilee year began with the auspicious inauguration by Pujya Shri Bhaiyaji Joshi, Sarkarewah of Rashtriya Swayamsevak Sangh. Since then, our special Golden Jubilee lecture series has brought us wisdom from stalwarts of great repute. And today, in the sixth lecture of the series, we are honored to hear Dr. Kumud Ranjan ji enlighten us on semiconductor technology, opportunities and challenges for Bharat. Dear children, the Golden Jubilee Lecture Series is a part of our institution's Vidyan Samskar. It is designed to connect you with the finest minds of our nation. These lectures show us how research pursued with focus, commitment and dedication becomes service to the nation and to the humanity. Let today's lecture inspire you to explore the vast world of semiconductor technology. May it ignite in you the resolve to identify your own research interests, to innovate and to serve Bharat with distinction. Jai Hind, Jai Bharat.
Thank you, sir. It is with immense pride and privilege that I introduce before you our chief guest and keynote speaker for today's program, Dr. Kumud Ranjan. Dr. Ranjan is a distinguished senior scientist from Nanyang Technology University, Singapore, and former scientist with DRDO in the Semiconductor Electronics Division from 2004 to 2008, spearheading TR module development for satellite C-band transponders, and has since advanced wide bandgap semiconductor innovations as an ex-senior scientist. In his 20 years of experience, he has developed expertise on semiconductor research, process integration, project management, and foundry development for gallium nitride and silicon carbide technologies applied in telecom, radar, satellite, and nuclear domains. He has to his credit collaborations with elite institutions including MIT USA, Ohio State University, Nagoya, GNS New Zealand, and NUS Singapore. It is an honor to know that he has co-authored publications with Nobel laureate Dr. Hiroshi Amano, the 2014 Physics Nobel recipient, while offering extensive experience in technology business, incubation, and global consultancy. May I request the honorable dignitaries on the dais to welcome and felicitate our chief guest and keynote speaker, Dr. Kumud Ranjan, by offering a memento shawl, Shrifal, as a token of a sincere appreciation and gratitude. Thank you, sirs. I request Dr. Peshwe, sir, to welcome Advocate Ulhasji Aurangabadkar with a plant sapling. I request Dr. Peshwe, sir, to welcome Professor Vilasji Deshpande with a plant sapling. Thank you, sir. I request Captain Professor Prashant Ambekar to welcome Shri Sureshji with a plant sapling. Thank you, sir. I request Professor Nitin Gaikwad, sir, to welcome our principal, Dr. Akhilesh Peshwe, sir, with a plant sapling. Thank you, sir. Today marks the International Day of Persons with Disabilities. On this occasion, we would like to recognize and felicitate the spirit of dedication of our administrative staff members, whose commitment quietly empowers the smooth functioning of our academic environment. I request Aurangabadkar, sir, to felicitate Bhushanji Patle with a plant sapling. Request Aurangabadkar, sir, to felicitate our very own Prachi Vishnu, that is Mona Tai, with a plant sapling. Thank you, sir. It is my profound honor to invite our Honorable President of Dharampet Education Society and the President of today's function, Advocate Ulhasji Aurangabadkar, to address the august gathering with his motivational words. Sir.
Honorable Dr. Kumud Ranjan, sir, my companions in Dharampet Education Society who are on the dais or off the dais, Principal Dr. Peshwe, the teaching, non-teaching staff members and dear students. When I came here, I only knew that today is National Advocates Day. And I had received a lot of compliments for the National Advocates Day. But we are fortunate that our college has remembered who are in service of the society in spite of something which they are lacking. The lecture series which has begun in 2018, I am really proud to say that it is continued in spite of all odds, including COVID also. I distinctly remember 2 lectures we had organized online. One of my friend, Dr. Shekhar Mande, was the speaker then, and second one I don't recollect the name, but he was a faculty from Bangalore, Dr. Shiv Kumar. I am really happy to note that the lecture series which has begun with the initial address by none less than Dr. Vijay Bhatkar sir is receiving a good response, and we are really fortunate that we are being addressed by the speakers who are of the same stature of Dr. Vijay Bhatkar, like Dr. who will be addressing us today. His profile is really inspiring. It is really inspiring for the students. While we are discussing for a few seconds or for a few minutes prior to this lecture, the discussion centered as to what the students of today should do. A point of concern was raised that basic science is being neglected. Or I may be incorrect in saying so, that it is being neglected, but it is not given its due importance. And Dr. Kumud has a lot of things to his credit, and he has done it with basic science. We at Science College are really fortunate to have our CDC chairman, Dr. Vilasji Deshpande, who also belongs to, or who also is a student of basic science. Friends, in the next month, in January, our Dharampet Education Society will be organizing yet another lecture series. It is an annual lecture series. And the subject will be Role of Youth in Vikasit Bharat 2047. We are fortunate to have our own alumni, Shri Vijay Chauthaiwale, to address us on that subject. Vijay Chauthaiwale is a well-known figure in national capital, and especially as far as the foreign relations or foreign or the programs of the Honorable Prime Minister are concerned. We are really happy to note that our own alumni, Mr. Vijay Chauthaiwale, will be addressing us on that particular subject. To achieve the target of Vikasit Bharat in 2047, the role of youth is important, and according to me, your role begins from the topic that we will be addressed today. Our Honorable Prime Minister and the central government recently, as we have noticed, is focusing on semiconductors. If I am not wrong, in the last month or a month before that, a conference or some seminar was conducted at New Delhi. Something was inaugurated. I am not. Yeah. So the subject which the Union of India is addressing right now will be an important subject to achieve the target of Vikasit Bharat in 2047, and we are really fortunate that we are here to hear an eminent speaker, an expert in that field, Dr. Kumud. So I welcome him on behalf of Dharampet Education Society, and without wasting any more time, I request the organizers to proceed further with the program. Thanks a lot.
Thank you so much, sir. The moment we are waiting for has finally arrived. I invite our esteemed chief guest and keynote speaker, Dr. Kumud Ranjan, to inspire us with his enlightening lecture and share his insights on semiconductor technology, opportunities and challenges for Bharat. Sir.
Good afternoon, everyone. I'm really very happy, and I don't know how to convey my thanks to entire organizing committee, President sir, Chairman sir, and especially Principal sir when I received message that I have to give lecture on this. But they just simply mentioned that कि आपको third आप हैं क्या भारत में? So I said yes. फिर उसके बाद एक दो दिन के बाद फिर एक मैसेज आया, टॉपिक आया. I have given so many lectures on a college, different colleges, universities. But really first time here, even plus two students as well as graduate students, mostly engineering colleges. So ये मेरे लिए, I'm really very happy. So sir, I'm really thanks to everyone. I just convey my thanks to everyone. Okay, so shall I start with today's topic, which was given to me, semiconductor technologies, opportunities and challenges for Bharat. So topic is really, this topic covers so many things. Just please change the slide. Next slide. So, मैंने कुछ प्रश्न लिखे थे पहले. So is it okay if I speak Hindi, English, both mix? Because just semiconductor क्या है? That is like when I joined DRDO, first 6 months training was given in Pune, Department of DIAT, Institute of Armament Technologies. I was basically electronics engineer, and then selected as a scientist from campus placement it was, and what scientists really do. During even training, it was basically not given the topics, basic sciences all, just it's a kind of attitude development for a research, as well as discipline, how to make yourself disciplined, because half of the training was given from scientists, different DRDOs, ISROs, and different scientific labs, and rest part was given by defense services like Army, Air Force, Navy. That time we realized, that time actually just after passing out the college, we didn't even understood the importance, but simply started in a one lab, SSPL, Solid State Physics Laboratory, Delhi. That was my first posting there. And my director was Dr. H.P. Vyas. And I just mentioned and pay my gratitude to him. Now he's no more. So he simply said, Kumud, you have 3 opportunities, like 3 divisions in semiconductor. because that lab is purely dedicated to semiconductor. So it's one is design, second is process fabrication, and testing and reliability test. But I don't give you any particular division. I want you to be trained in all the divisions. And that was exceptional for me. And after 1 year, I was placed in GATEC Hyderabad, gallium arsenide, that is pure semiconductor foundry for defense and space applications. Like as mentioned in the introduction, work for some satellite transponder, TR module, it's a transmitter and receiver development. So my purpose is to say that I started my career in a system development. Like I have to develop complete transmitter receiver using made in India chips that time for CatroSat satellite. But what happened in couple of years that I was involved in both design, processing, even testing, and then assembly and testing and the reliability side. So in DRDO, 4 years, I was not developed myself as like, जब लोग पूछते थे कि okay, what do you do in research? I was doing all the three things. So I faced some issues. I couldn't say that in design particularly I do this semiconductor device design or semiconductor device fabrication, because in the research lab, particularly even you have to go very at the root of this. Someone is working on the diode that I did, I can show you later, and the entire life worked for one diode development, like Professor Hiroshi Amano, he's 2014 Nobel laureate. I got some opportunities. So in that 4 years, first 2004 to 8, somehow I couldn't become like as a scientist. It was like integration as well as understanding the system, understanding the requirement. And then suddenly one day, one group of Bharat Electronics Limited researcher, basically it's GM general managers, they came and they gave one module, just like a kind of mobile size. आपको ये develop करना है. This is for new radar applications, radar, different frequency range. So that time in 2008, I encountered what is gallium nitride. Because for the same things, different material, gallium arsenide, like all are having ideas of semiconductor? Basic? Okay. So then I realized, because that time we proposed also Indian government gallium nitride things, but in India, not a single lab was working on gallium nitride side. So somehow I moved out from there and went to IIT Kharagpur for especially GAN research and left, and then finally Singapore. So चलिए start करते हैं इन प्रश्नों के साथ, like semiconductor technology, हमारी life में इसका क्या role है, like everyone knows. And then what is the node, like nowadays, those who are really aware of this, some technological part, some nodes are there. I may come across this. And Bharat, like what is the current situation in India? And what are the opportunities that as a part of slides and challenges? So next, please. I can just show my case, like this was in NTU. Even in university, I was just working in one process side. And it's a journey of last almost 20 years. How they started from some basic sample, you can see the left corner, top left, like a small samples, and finally landed to the full 4-inch wafer. And so in Singapore, research is not a research until unless it is developed as a product or and utilized as per the specs required by the system people. No one leave, even the entire funding agencies, government funding agencies, cannot leave you just up to the research level. So we were bounded, we are committed, and wahan se, like there I learned one thing, that research means we have to develop, after the research we have to develop the product, we have to deploy the chips in the system. Next. Semiconductor fab, how many of you know semiconductor fab? Have you ever seen any kind of, any foundry, any fabrications? ठीक है, जैसे हम like simply we roti बनाते हैं, like starting from the simple atta to roti. It's just like same thing from silicon to how we develop this one. I will show you. These are our Singapore foundry, small foundry. It's not the big foundry because even we can't take pictures, but some of the courtesy slides are here, courtesy pictures are here from NTU side, from A-Star, Agency of Science and Technology Research. Really, Bharat mein, we cannot take any picture. Sir, I think many of us cannot go DRDO lab and see this semiconductor facilities there. So we are, as sir mentioned, as a part of revolution of basic science, we are also working on to that policy makers, like how our students can visit and see some of the research labs. Next. Yeah, this is just semiconductor wafer, and finally it's a fabricated chip. I will explain like what is a metallurgical grade and how is a semiconductor grade, or hum kahan hai. Next. So, okay, let's start. What is semiconductor? Simple. Conductor, bad conductor, good conductor, conductor and bad conductor के बीच में, क्योंकि I'm really cannot give you more details on this one, but basic हमारी life इसी predictable में है कहीं ना कहीं. Whatever we do in any kind of research, especially even kind of material science to electronics to space related things, so we have a material. And one thing before this, I just want to let you know that हमने systems start किया. Like I started as a system researcher and finally landed to the crystal, a basic, very basic material science. Typically, it is reverse actually. You start from the entire system. My whole journey of last 20 years, it was reverse actually. I started from the transmitter receiver module for radar and landed to the basic science because I really realized the basic science ka importance. That I realized in Singapore actually, not even here in DRDO. And let's see during these slides, I can explain why basic science is the most important thing and how we should, as President Sir mentioned, how and like we have to again do some revolution in this one. Why not start from this school, this college? हमने जो पढ़ा है अपनी लाइफ में 10th में 12th में उसमें और डीप जाना है. इवन करियर में like we go wherever, but we don't. We always has to carry our basic physics, basic science. Next. Okay, some of the applications. Everyone knows mobile, laptop, computer, all the commercial devices. Even gaming. Nowadays, NVIDIA, know about NVIDIA and all. Last conference, I heard that all the processors, like previously we used to say that, hey, our processor is this much of frequency, example 2 gigahertz, 3 gigahertz, 5 gigahertz. So now processor comes with memory, integrated. And CPU is, now people are not talking about the CPU, all are talking about the GPU. So these are some revolutions in semiconductor technologies for commercial applications are there. So these are the many applications, semiconductor in electronic side, photonic side, sensors. Just today morning I used a couple of even LED bulb. All are working like connected with my Wi-Fi. Like I have to turn off and on from anywhere just to save some energy as well as to upgrade ourselves, like what is going on. But at the same time, I dismantled one bulb also, just understood the complete block diagram of things and started with some of the students. Those are associated with me as interns in India, here in Nagpur. Like आपको इस पे काम करना है, रिसर्च करना है. Because बहुत सारे applications हैं. जैसे हमने जब हमारे पास कंप्यूटर था, हमें 5 volts लेने होते थे तो हम PC से प्रिंटर पोर्ट से ले लेते थे, rather than we have to had no facilities. So sometimes we have everything, but we don't know how to utilize our things. Next. Like I already, this is my actually gallium nitride related things. GaN research separately. Okay, go to the next. I'll not explain much. Yeah. So as I mentioned, I started from that side, communication side. All the different frequency range. My area in semiconductor electronics, especially in RF and microwave. So I just keep some slides here because we have to understand opportunities also, challenges also. So, and if you see in the like yellow color is all digital part of digital electronics, and right side is all RF, high frequency. You are sending the signal from here to even space. So previously even ISRO was using as a gallium arsenide based. What is the difference? And now almost every country, those who are very strong in defense technologies, they have developed gallium nitride technologies for this transmitter receiver development. And this is also quite popular in the latest Bharat-Pakistan, some mishaps, whatever the things happened. Some of our missiles use the GaN-based transmitter receiver as well as seeker. Okay, next. So, semiconductor has some own limitations from material to material. Sir is there, renowned physicist, and other professors are there. He knows that this is just a spectrum. जैसे अभी हमें किसी चीज़ को कभी present करना है, जैसे semiconductor, see the first dotted lines is written as the 5G, is previously all the semiconductor based devices used for 5G applications. A low voltage application, silicon always used for the low voltage application. That's why हमने जितने भी processors, सारी industries, जितने भी commercial devices, less than 5 volts जो applications हैं, silicon based. Gallium arsenide, slightly higher side, 10 to 15 volt. It's like, I cannot explain कि ये क्यों होता है, it's a breakdown voltage and all. But the gallium nitride, that was area, this is the reason I moved out, that this is called the material property. So I will explain, let's see a little bit. Okay, so satellite communication, automotive radar, military systems require compact devices because has to send all the system requirement, always they say that, hey, I need a small, we call it form factor. So small devices like size point of view. But other issues comes, जब हम size reduce करते हैं, then lot of challenges, thermal aspects, many things comes in the system. Just next. Okay. So, see, as I mentioned, the last you see the box as a subsystem is a transmitter, complete. See, one before, it's a packaged semiconductor chip. किन्होंने packaged semiconductor devices देखा है? Semiconductor chips? नहीं? But all the modules, whatever you see, is basically packaged devices. And then is one transistor. The yellow one is just one transistor. Just for reference, I'm giving the size of that transistor. Its size is is fabricated 200 micron by 600 micron. So it's less than 1 mm by 1 mm, the yellow one. 1 mm, can you imagine? Because this diameter of our hair is also 40-50 micron, roughly. So size is, yellow one is 200 micron, the width around, and this is around 500 micron device. So one transistor itself is sufficient to amplify the signal, but that is, okay, this left side, just see the wafer, that's a 4-inch wafer. और मेरा research था GaN on diamond. It's like I got a diamond wafer, sir, $20,000 US is one 4-inch wafer, semiconductor wafer. That was diamond wafer. I also did a lot of devices fabrication on that one. That is the processed GaN, second. The first one, now come to the first. That is the most important we are missing here. Diode, have you heard diode? सभी ने diode सुना, transistor, resistor. But कभी break करो उसको आप. तोड़ो, just see as much as you can go inside. Hardly few rupees you can get. At least take a look कि उसके अंदर क्या है. See you can see up to this third level. The first is, we call it device, how we can design a device. जैसे हमारे सामने एक challenge आया, just example, we have to develop one 10-watt power amplifier for this frequency range. Example, 10 gigahertz for radar communication system. So that is the last one. So I get the specifications from the system people. Example, here in India, Bharat Electronics Limited is the company, is Bell, developed that system, even the entire system. So as a semiconductor scientist, or we can say is a semiconductor researcher as well as the developer, come to this, drop down to the first level. What type of device we have to develop? So this brainstorming session, normally we used to do there in Singapore, from the system to basic device. Or good thing is, it's like system people sit together with the process integrator, with the device researcher, with the material scientist, all sit together first in the presence of the required defense services in Singapore. They give these specifications of the last one. So all scientists, they kind of brainstorming session we do, and then we take this project. Here, आप लोग जब अभी आप कॉलेज में जाओगे, कॉलेज में अभी आपने कभी प्रोजेक्ट लिखोगे आगे, like DIT, have you heard? Department of Information Technology, DST, Department of Science and Technology. So these are the funding agencies, like they give funds for the research, even, but up to some TRL level. Have you heard about technology readiness level? तो ये कुछ आपको अगर एक डिवाइस डिजाइन करना है, like in, we must have some collaboration with the VNIT. So VNIT has some facilities here, not the entire facilities, but कुछ तो facility है उनके पास. इससे अगर यहाँ के बच्चे, हम अगर VNIT जाके उनके साथ रिसर्च करते हैं, कोलेबरेट करते हैं, एटलीस्ट एट द ग्रेजुएशन लेवल हमारे पास सेमीकंडक्टर का कुछ तो आइडिया होगा. नेक्स्ट, या चलिए, दिस इज वेरी इंपॉर्टेंट फॉर नॉर्मल स्टूडेंट्स. सैंड, एवरीवन हैज सीन? ओके, फ्रॉम सैंड टू सिलिकॉन. So this is the biggest challenge for India. We have not developed commercially available silicon wafer in India so far. So many DRDO labs is working on, so many CSIR labs are working on in this one. Correct, sir? Basic labs are there even. So if we have to really develop this technology, semiconductor technology, हमें सबसे पहले, like we have to dig these labs. Why not has developed from just first stage, sand to silicon? Why not we have developed? क्या problem क्या है, like? So we have to identify the problem. Any kind of like research problems first, and then from silicon to wafer, semiconductor wafer, and finally chips. So I'll go just in the next slide. I'll show you. Just please next. Next slide. I think I missed one slide in which just some equipments are there. I think engineering में हमने पढ़ा था. I don't know. Here is like basic science how we developed. So from the normal sand, like carbon and silica, SiO2, how it makes molten stage, and then finally metallurgical grade silicon, and then finally semiconductor grade silicon. So okay, like let's see what are the positions, like Bharat कहाँ पे हमारे इस पूरे. Just see that these are the foundries. These are the semiconductor foundries worldwide. आप देखो, North America, means especially America side, Europe, so many foundries, and these are the old data actually. I think couple of 5-6 years back data. Even Korea, see how many foundries are there. Japan, Taiwan, see Taiwan. So many foundries are there, semiconductor foundries. So, and after 1980s, I think, these are the foundries developed. So where we missed it? Jaise, like, what is the position of Bharat? Because that was the time in 1960, if I hope I covered this, as a, like 1960 roughly semiconductor devices came first time Even research was done in 1948 itself, when I think 48 May, Dr. C.V. Raman got the Bharat Ratna Prize, Nobel Prize. 30. So, 1960, okay, we can say that 1960 India was going on the first industrial phase, establishment phase, application-wise. But 70s, so then I started digging all Panchvarshiya Yojana, 5-year plan. Have you heard about 5-year plan? Go through your 5-year plan. And being a student, I cannot make you make judge on the political parties, but you are policy maker, futures. आप देखो 5-year plan में, you find out कि उसमें कहाँ पे हम मिस कर गए. जब ये वॉइस आपके तरफ से आएगा, then at least next 10 years, next 20 years में हम फिर से यही नहीं कहेंगे कि we missed this bus, right? So it is my advice as well as request. Make yourself as active, like transistor is active device, resistor, inductor, capacitor are passive devices. Make yourself active. So this is the reason कि last 20 years, 30 years or 40 years में ये voices नहीं आए हमारे यहाँ. I heard in 2006 first time कि semiconductor plant आ रहा है एक इंडिया में in Hyderabad. But still we are in the same position 2 years back if I say it. Now there are a lot of advancement is going on. So अगर रियली आपको अपने कंट्री, अपने देश, अपने राष्ट्र के बारे में भी सोचना है आगे चलकर, तो आपको अपनी वॉइसेस को जहाँ भी आपको लग रहा है कि यू जस्ट वेर एवर यू अंडरस्टैंड वी आर मिसिंग इन टर्म्स ऑफ पॉलिसीज, सो यू कैन रेज योर वॉइस, यू कैन राइट टू एनीवन. चलिए, द करेंट सिचुएशन इन इंडिया, वी आर इन द एस्टैब्लिशिंग फेज. 2-3 जगह पे फाउंड्री बननी शुरू हुई है, जस्ट लाइक बट फर्स्ट फाउंड्री assembly packaging ki, not easy like complete semiconductor device foundry. Okay, go next please. Okay, as I mentioned, 60s like first semiconductor ICs, then 80s like Japan has developed, many countries started developing. Actually this is mainly for GaN technologies. Okay, next please. Okay, so some of I think last 10-15 years, because when I was in college, in my batch, there was only one computer, and that RAM, I remember 256 MB RAM in 2004, yes. So, ये just मैं एक आपको basic एक road map दिखा रहा हूँ, like from 1970s around. So, when we call it semiconductor technology, what does it mean, semiconductor technology? कोई idea? किसी भी चीज़ की टेक्नोलॉजी जब हम बात करते हैं, जैसे हमने पहले सुना लाइक 2G, 3G, 4G, नाउ 5G, एंड नाउ पीपल हैव डन रिसर्च ऑन 6G. 6G पे भी डिवाइसेस आ गए हैं मार्केट में. सो इट्स लाइक वी ट्राई टू अंडरस्टैंड व्हाट इज द की पैरामीटर ऑफ दिस टेक्नोलॉजी. सिमिलरली इन सेमीकंडक्टर, transistor is the most important key parameter. Transistor, like how many heard about the NPN transistor, PNP transistors, or FET, field effect transistors? Okay, so just like आपके घर में जैसे गेट होता है, वैसे ही डिवाइसेस में भी सोर्स, ड्रेन, गेट होते हैं. So all, it's not exactly gate, but it's a node. Somehow it is related to gate. So that is the technology. 10 micron is like one like transistor. Gate was 10 micron example. It's a node, actually not gate completely. So see, in 70s, your equipments can develop the, it's not the design or something, it's equipment related restrictions were there. So we landed 10 micron. ठीक है, उसके बाद 1985, we narrow down it, like 1 micron आया, तो हमारे same size में transistors, अगर आपने कभी मूर्स लॉ पढ़ा होगा, नहीं तो ऐसे ट्रांजिस्टर्स सेम साइज में ट्रांजिस्टर्स डबल होते गए, बिकॉज ऑफ हमने गेट के साइज को कम किया, नोड टेक्नोलॉजीज को इम्प्रूव किया, साइज रिड्यूस किया. सो लाइक नाउ इस डेज आपने देखा कि प्रोसेसर्स, छोटे छोटे प्रोसेसर्स में ट्रिलियन ऑफ ट्रांजिस्टर्स आ गए. सो 0.18 इज लाइक 180 नैनोमीटर, 0.18 माइक्रॉन. अच्छा, माइक्रॉन अंडरस्टैंड्स, माइक्रॉन, नैनोमीटर. Okay, so why for me it's nanometer, I am very comfortable because all the research done in the device, sometimes I feel that I'm in two-dimensional electron gas, because how a transistor, working principle, and then during the research, sometimes you feel it. If you continuously research, like last 2000, I think 12 to 20, 8 years, I did research. I had no contacts, no here and there. I think 1 micron. So far, SCL is using 0.18 micron. So far. Still, 2020, अभी भी उनका एक chip गया है satellite में. It's a 0.18 micron. Even they have developed some research, but final product is with the 0.18. And now, this is 5 nanometer, and even 3 and 2 nanometer devices that technologies has come in the market. So, India, in 2006 में जब हमारे पास एक ऑफर था कि एक कंपनी आ रही है, इट्स लाइक फ्रॉम जर्मनी, एंड दे वेर गिविंग 65 nanometer, 90 nanometer technologies in 2006. But that time world other countries were working on around 65 nanometer technologies. ये जो मैं आपको बता रहा हूँ, this is the just कि एक इंडस्ट्री 2006 में आते आते कैसे रह गई, इंडिया में नहीं आई, and this is the reason that at least again we lagged behind 10 years minimum. So just think of it, कि 2006 में अगर even 90 nanometer, and what was the reason? एक reason ये भी था कि like company wanted more subsidies, क्योंकि semiconductor is like very huge capital intensive, like foundry, एक बनाना ही foundry आज के date में 20,000 crore rupees minimum, at least if you have a nice like 10,000 wafers per month, 20,000 wafer per month. So इतने बड़े investment typically टाटा ने तो नहीं किया, रिलायंस ने नहीं किया. आप सोचो इतनी बड़ी इंडस्ट्रीज है आपके पास, किसी ने क्यों नहीं लगाया सेमीकंडक्टर इंडस्ट्री? व्हाट इज द रीजन? दिस इज द रीजन कि एटलीस्ट इट शुड टेक आई थिंक 15 years, we call it ROI, return on investment. And this is also possible if government has some policies, plans, because technology development itself has some timeline. By the time new technologies come in the market, and if you have like import, export, there are some regulations, some duties, free and all. So that's why any Indian industries were not interested to invest in semiconductor. So 2006 that company नहीं लगी क्योंकि गवर्नमेंट ने अप्रूव नहीं किया 90 nanometer को. They wanted, government, when I call it government means government, they wanted 65 nanometer और 45 nanometer. But 65 nanometer और 45 nanometer की टेक्नोलॉजी लगाने के लिए जितने फंड चाहिए थे और जितनी गवर्नमेंट का सपोर्ट चाहिए था वो नहीं मिला, कंपनी बैक ऑफ कर गई. और 65 नैनोमीटर की अगर उस समय 90 नैनोमीटर की टेक्नोलॉजी जर्मनी में जो आउटडेटेड हो रहा था वही इंडस्ट्री यहाँ लगती, एटलीस्ट लग जाती, तो आज हम 22 नैनोमीटर, एटलीस्ट 40 नैनोमीटर और 28 नैनोमीटर पे सेल्फ रिलायंट होते. सो आई जस्ट मेंशन दिस कि आप कभी किसी चीज़ को समझो पॉलिसीज में तो जस्ट ट्राई टू अंडरस्टैंड एटली, एंड दिस क्वेश्चन आप आपस में भी डिस्कस करो कि वाई वी आर लैगिंग बिहाइंड इन सेमीकंडक्टर. ओके प्लीज नेक्स्ट. ओके चलिए, इंडिया में धोलेरा इन गुजरात, टाटा एंड PSMC मेगा वेफर फैब 28 to 110 nanometer as they mentioned लगा रहे हैं. 28 सानंद इज अ माइक्रॉन इज अ कंपनी, जितनी भी मेमोरी डिवाइसेस आज के डेट में आप रैम से लेकर के बहुत सारी टेक्नोलॉजीज है उसमें, बट फाइनली यू सी द प्रोडक्ट. सो माइक्रॉन इज वन ऑफ द like biggest company in memory devices. So Sanand में वो लगा रही है. Assam, Tata's 27,000 crore semiconductor assembly and test unit. It's assembly unit. Like the wafer will be fabricated outside, or finally they will import all these wafers and then assembly and packaging. And at least we can have indigenous packaged devices. हमें क्या फायदा होगा उसमें स्टूडेंट्स को? आप बताओ आपको क्या फायदा होगा when you see at least assembly and packaging first time. So at least our engineers, our like researchers, our scientists, our in this one workers, at least we will know कि packaging की technologies में we will have at least one level, so that next level में पैकेजिंग इक्विपमेंट्स यहाँ पे बन सकते हैं, पैकेजिंग से रिलेटेड यहाँ पे कंपोनेंट्स और केबल बन सकते हैं। जैसे एक एग्जांपल मैं दे रहा हूँ, लाइक IIT दिल्ली हैज़ टू रिपेयर वन equipment, semiconductor equipment, we call it tuner. And for repairing, it's not repairing, for servicing, we need some chemical. And that chemical came from Canada. तो ये हमारे लिए बहुत, बहुत सिंपल है, बट ये हमारे लिए बहुत पेनफुल है एज ए रिसर्चर कि एक क्या हम केमिकल और एक कॉटन नहीं बना सकते हैं उस ग्रेड का जो सेमीकंडक्टर मटेरियल में, सेमीकंडक्टर इंडस्ट्री में यूज होता है? एक एडेसिव नहीं बना सकते हैं क्या हम? So like it's a, once semiconductor industry comes, it's not only that industry, it's like associated hundreds or different type of industries होंगे. And like this is our next generation students जो भी हैं, आपको बहुत benefit होगा. And like let's see, I'm hopeful जल्दी शुरू हो जाए. So Orissa में like one of India's first semiconductor silicon carbide wafer in IIT Bhubaneswar in collaboration with one company has developed 8-inch silicon carbide. So आप जितने भी power devices like we see, MOSFETs, an inverter, EV, railway, grid, that uses from 200 volt to 10 kV. So for that we need semiconductor wafer. Like suppose we have developed foundry, fine, but the wafer we are buying from outside. And one day, if your other country, like those who are supplier from US or China, because of geopolitical war, if they were restricted by US that कि आपको ये वेफर सप्लाई नहीं करना है, बेयर वेफर, then what will happen? So these are the factors like important for Indian government, for policy makers, that not only semiconductor foundry, we have to develop, as I mentioned, from raw material to semiconductor wafer. Until unless we do, तब तक हम self reliant नहीं होंगे. So विकसित भारत के लिए, as sir mentioned 2047, विकसित भारत, तो हमें इस पूरे ब्लॉकचेन में एवरीवेयर वी हैव टू डेवलप. चलिए नेक्स्ट. सो ओके, एज ऑलरेडी आई मेंशन्ड कि टाटा ये अलग अलग इस पे काम करे. प्लीज नेक्स्ट. हाँ, नेक्स्ट. दीज आर द सम like more details what they are doing. Okay. Oh, I just put there sand to silicon. So we don't have any equipment here in India. And in case, I give you one example, in SSPL में अगर ये equipment है DRDO के lab में, and if you see hundreds of components as well as even furnace, everyone is aware of furnace. Furnace क्या होता है, correct? लेकिन आपको एक भी components इसके इंडिया में नहीं बनते हैं. एक बार सर मेरा example है, 2000 during this COVID period, I was associated with one Canadian company. I just left Singapore and came here. After PhD, and Canadian company were interested कि सर आप थोड़ा help करो, and like even in application side or technological side, and they had again some system issues, some system problem they had, and simply I had to find out. They sent all this everything, chemical components, even nut, screw, and everything. One was missing actually. पूरी दिल्ली में हमने सर्च किया, वो उस ग्रेड का एक जगह मिला हमें. सदर दिल्ली में कहीं पे एक जगह, कितने ऑलमोस्ट हंड्रेड्स ऑफ को हमने रिच किया, एक जगह वो कंपोनेंट उस ग्रेड का मिला. देन दे रियलाइज कि सर आप डेफिनेटली जर्मनी का कोई इक्विपमेंट होगा. देन तो आई सेड नो इट्स फ्रॉम कनाडा, बट एक्चुअली ही वाज राइट. कनाडा बॉट दैट वन फ्रॉम जर्मनी एंड देन शिप्ड इट हियर. तो वो बताते नहीं हैं ऐसा. चलिए, तो दिस इज द रीजन कि हम इक्विपमेंट में भी पिछड़ गए. टेक्नोलॉजी is one thing, semiconductor technology, it's like manufacturing equipments. So we, as I mentioned, कि हमें equipments भी develop करना होगा. Next. हाँ, Micron, as I mentioned, ये भी कर रही है, ये भी धोलेरा में. Next. Kenis, yeah, next. Tata Semiconductor, as I mentioned. So government, so पहले नहीं किया, अभी suddenly किया. What is the reason? क्या हुआ अचानक अभी सारी companies ने invest करना शुरू किया? It's like huge support from government. 78,000 crore, that time actually it's a 10 billion US dollar. So that time it was 78 rupees, now it's 85, 86 rupees. So it around 80 to 90,000 crore rupees government ने subsidy दिया इसमें. It's subsidy, it's like 50% by central government. And like अभी हमने महाराष्ट्र में propose कर रहे हैं, तो state 25% by state government, तभी जा करके like we can do something in semiconductor. Otherwise, no businessman can just put their money in this semiconductor. Next. ये हमने ऑलरेडी डिस्कस किया, एक वेफर से लेकर के एक आईसी जो दिखती है, तो पूरा प्रोसेस है एक लाइक बेसिक फिजिक्स, आई विल नॉट एक्सप्लेन, ओके, बट wherever I think this is repetitive. So where are actually missing that India में we don't have real semiconductor wafer where we can make the device. Like SCL Chandigarh, there are some of the companies, they do some process, small level, passive devices, op-amp, ICs, सबने सुना है ना, op-amp, ICs, ट्रांजिस्टर, रेसिस्टर. आपने ज़्यादातर ये पैकेज भी अभी बाहर से हुए, लेकिन अब इंडिया में एटलीस्ट पैकेजिंग शुरू हो गई है. सो वेफर आ गया है एंड प्रोसेस्ड वेफर एंड देन पैकेजिंग. नेक्स्ट. ओके, नेक्स्ट. सो आई थिंक विद द टाइम these are the some of the application related semiconductor technology applications. चलिए नेक्स्ट. या कार, एक छोटी सी जस्ट स्टोरी बताता हूँ. अच्छा, ओके. सो सी इन 1950s this slide just show that कि एक कार में, एक जो कार means like when we say it's a automotive, like इसमें इंजन के बारे में बात होती थी, एरोडायनेमिक स्ट्रक्चर के बारे में बात होती थी, मैकेनिकल स्ट्रक्चर के बारे में बात होती थी, इलेक्ट्रॉनिक्स के बारे में कार में कभी पहले बात नहीं होती थी. आज के डेट में आप देखो 50% कार में सेंसर्स की बात होती है, इलेक्ट्रॉनिक्स की बात होती है. सो वैल्यू एडिशन फ्रॉम द electronic side increases in 1950 less than 1% because of there was no semiconductor that time. थोड़े मोरे electricals थे. Now it is more than 50%, and if you go the higher version, like even the not only the Wi-Fi and all different kind of sensors are integrated. So आने वाला समय sensors का है. It's like wherever we are sitting, everything is passive now. Wall, everything will become active very soon because every flexible material has come. Not only for the solar, for many things. So why we will leave just as it is. Whatever the energy we are like using and some part of the wasting, we will try to reconvert it in a different way. Next. So ये हमने already एक में cover किया कि 1950s में जब एक ट्रांजिस्टर, सिंगल ट्रांजिस्टर बना. So अभी हमारे पास almost 5.2 billion transistors. ये भी पहले का डाटा है, ये भी. The largest CPU has 5.2 billion transistors. Next. Yeah, already discussed some of the. Yeah, okay. So this is just one application side. I'll just take a few minutes. Mobile phones. See the first, this one kind of column. So in mobile phone, see memory takes around 39% of the entire mobile phone. Logic side is the processor side, mainly it's a global semiconductor sales by application market, this one slide is there. And digital side is all 33%. So these are the different application side. So based on these applications, industries are interested. वो देखते हैं कि किस, जैसे बहुत सारी industries like only for PC side, consumer electronics, industrial applications. So according to that, this volume changes. Next. Okay, global semiconductor applications. Most is like communication side, PC and computer is 32%, automotive. Okay, next. Yeah, semiconductor mission, as I mentioned, already started. So just be part of that and try to understand semiconductor as a student, semiconductor physics. As like if you are a job seeker, try to understand semiconductor applications, some of the part of like even suppose now there are hiring for some companies, those who do some, what questions they will ask? They will ask semiconductor के बारे में क्या पता है? वो नहीं पूछेंगे. वो ये अगर आपने PN diode भी बता दिया आपने ठीक से कि what is P type, what is N type, I don't know how many of are well versed of this. So it's like just we have to focus on basic science. So more or less, even if you go for masters or PhD, purely they will ask you very simple questions, very basic questions. So please be with your basic science, like give the values of your basic physics. Yeah, next. These are some of the slides, okay. Next. Yeah, as you know, IT ministers that time, Ashwini Vaishnav also like had hope This is 2 years back news that we expect more than 100 units, and we are truly, I can say that I can appreciate that. At least I can see I attended that conference, sir mentioned Semicon India. First time I have seen many Indian companies at least started packaging side and design side also. Next. Yeah, these are the Indian companies. Okay, next. Yeah, I already mentioned some of the histories, like what happened with 2005 and 6, and some of the remarks. This is very important while we discuss with some people and even policy makers. Next, because I'm going to meet Indian Semiconductor Mission CEO, and we'll discuss all these things. Some of the IITs has started semiconductor training, basic. So even as a student, you can write to them, you can just simply mail them, you can find out where are these training started. Next. Okay, next. Okay, I think overall I have discussed everything about this basic application side. Some I didn't discuss much research side, sir. But if any, I will be available in, if any of even technical lectures is required, more on semiconductor side or even in detail with the particularly students of that classes, electronic side. So I can come if some time is required. So that's all I think I can share with you now, as of now. So any questions? आपको कुछ भी पूछना है तो आप बताइए. हाँ.
सर आपने अभी कहा कि जैसे बेसिक फिजिक्स बहुत इम्पोर्टेंट है सेमीकंडक्टर मैनेजमेंट में. तो एक बेसिक करियर पाथ क्या है, क्वालिफिकेशंस क्या नेसेसरी है सेमीकंडक्टर्स में काम करने के लिए? क्या अगर मुझे स्टार्टअप बिल्ड करना है सेमीकंडक्टर्स के अराउंड, तो कौन से टॉपिक्स हैं जिसमें काफ़ी प्रॉफिटेबल होगा सर?
Profitable, right? Career? Profitable in terms of money.
प्रॉफिटेबल या फिर काफ़ी इंडिया के लिए?
जी. So, your name? वैदे ने एक क्वेश्चन किया कि उन्हें स्टार्टअप करना है या फिर लाइक शी हैज टू अंडरस्टैंड सेमीकंडक्टर में बेसिक फिजिक्स विद द कैरियर. So if you are from physics background, so device, okay, if you are from physics background, so device design, at least at this stage, I can say start with the designing of the device. Many companies world around, they have a process development kit, PDK. Just take that PDK, it's a kind of tablet. Qualcomm का नाम सुना है आपने? Qualcomm had no foundry, but दुनिया की सबसे अच्छी चिप उसके पास थी एक समय. तो उन्होंने डिजाइन किया. जैसे एग्जांपल अभी आपको बताता हूँ, आपने एक डायोड डिजाइन किया, आपके पास पीडीके है, आपने डिजाइन किया, बेसिक फिजिक्स यू अंडरस्टैंड, राइट? So based on the physics, right, you understand the electron mobility and all this, the doping, if you are from physics, right? So आप एक डिजाइन की कंपनी स्टार्ट कर सकते हो without having much investment. We call it fabric design, and government has given incentives for the design. So you can think of even career के point of view, if you are like later stage, you want to go in the masters or PhD. So with the basic physics, device design. So your device could be like one of the benchmark. I didn't share much of the slides. I developed a device in 2014. That was the benchmark that time with worldwide. The highest R parameter in terms of the breakdown voltage and the cutoff frequencies. So then the design can start. Anyone else?
You told us that there are various node sizes, right?
Yeah.
So how do node sizes affect the power efficiency and performance of the semiconductor chips?
Power efficiency and performance. Again, performance is very like qualitative term. You have to very narrow down what is the performance, means what type of performance. Performance like whether it's a speed point of view or it's like a breakdown. Lot of parameters are there in terms of performances. Example, if you have a large gate, so breakdown voltage will be higher. So suppose I had to develop one transistor for transmitter application, which can sustain, example, 200 volt, right? And one device is told that can sustain 1000 volt, and one is 10,000 volt, example, and one is just 5 volt. So 5 volt to 10,000 volt. So if I take all same material किया, because every material has also limitations. अभी हमने एक मटेरियल को रखते हुए अगर हमने नोड साइज रिड्यूस करेंगे तो एग्जाम्पल उसकी फ्रीक्वेंसी बढ़ेगी. देयर आर सम प्रिंसिपल्स इन दैट, बट उसके ब्रेक डाउन वोल्टेज कम हो. तो दीज टू मेजर पैरामीटर्स आर देयर. यू कैन इवन अंडरस्टैंड that lot of other applications are. So that's why when we narrow down, make it 3 nanometer, 2 nanometer. Size, the number of transistors they have increased. If number of transistors is increased, of course, some problem they can do multi-processing, multiple things at a time. So ये भी है. और yes, I think this row is done. गुड. इनका क्वेश्चन ये है कि एक रिसर्चर के अंदर क्या होना चाहिए, कैसे पर्सनालिटी होनी चाहिए एक रिसर्चर. पर्सनालिटी मीन्स देखो आप सभी रिसर्चर हो, सिर्फ फील्ड अलग अलग है. हमने दिन रात तो कुछ ना कुछ रिसर्च करते ही रहते हैं. चाहे वो मोबाइल पे कुछ सर्च करना है, बहुत लोग सर्च करते हैं, बहुत लोग रिसर्च करते हैं. कंबाइन करके जो पावर ट्रांसमिट करना है तो पावर कम डिवाइसेस यूज किए गए. सो दिस इज वन थिंग. ये क्यों हुआ? जियोपॉलिटिकल वॉर इज वन थिंग. ज्यादातर इसमें ऐसे में यूज होते हैं हायर स्पेशली ऑटोमोटिव में बहुत सारे पावर इलेक्ट्रॉनिक्स में सिलिकॉन कार्बाइड. तो उसकी शॉर्टेज हो गई. सिलिकॉन नहीं अफेक्ट हुआ था. That means our PC related things, laptop, PC, mobile related things ज़्यादा affect नहीं हुए. तो इसीलिए उस समय काफी न्यूज़ बना क्योंकि पावर we are like India is like that was user, right? तो हम हर चीज़ इंपोर्ट करते थे सारी चीजें. तो उस समय सेमीकंडक्टर टेक्नोलॉजीज शॉर्टेज के कारण हमारी सारी पॉलिसी मेकर्स पहले से अवेयर थे, बट दैट टाइम उन्होंने इमीडिएटली पॉलिसी मेकर्स, नीति आयोग ने काम करना शुरू कर दिया उस पर. इनफैक्ट इससे पहले से कर रहे थे, बट उसके बाद उन्होंने काफी आगे फाउंड्रीज को तुरंत फंड करना, जो फाइल पहले इवैल्यूएशन में ज्यादातर रहती थी वो फाइल को रिलीज करना शुरू किया. तो ये सेमीकंडक्टर अब वो शॉर्टेज कम हो गई है. जैसे एक एग्जांपल देता हूँ, टोयोटा प्योर प्ले कार की कंपनी, राइट? टोयोटा को इलेक्ट्रॉनिक्स से क्या लेना देना, उनके बस कुछ पार्ट्स उसमें लगते हैं कार में, हालांकि हमने देखा है. टोयोटा ने इन्वेस्ट किया जापान में सेमीकंडक्टर फाउंड्री में, 4% इक्विटी लिया एक कंपनी का. सो दैट इज अ रिवॉल्यूशन. सो एटलीस्ट क्योंकि उनकी अपनी ब्रांड वैल्यू है तो उसको कम नहीं होने देना. तो इस तरह से अब बहुत सारे लोग सेमीकंडक्टर पे काम करना शुरू कर. देखिए, आत्मनिर्भर पूरी सेमीकंडक्टर टेक्नोलॉजी में तो हम तब तक नहीं हो सकते हैं जब तक कि हम मटेरियल साइंस में स्ट्रॉन्ग आत्मनिर्भर नहीं होंगे. Yes. 99 points. Sir has clearly mentioned. Yeah. So exactly. So it's already. Do you have time? Couple of minutes. Okay. When जैसे सेमीकंडक्टर जैसे मटेरियल है, आप कहते हैं कि हमारे पास सिलिकॉन है, गैलियम है, हर एक मटेरियल है हमारे पास. तो so far we heard silicon or any material. First time we heard for battery, lithium refinery is going to be started in Nagpur. 1,000 crore investment is going to be. तो पूरी टेक्नोलॉजी मटेरियल की, इसलिए मेटलर्जिकल साइंटिस्ट, मटेरियल रिसर्च हमारे इंडिया में बहुत पीछे रह गया बिकॉज ऑफ हम लोग सिर्फ एप्लीकेशंस में थे टॉप लेवल पे. दिस इज वन रीजन. तो मैंने सर इसके लिए IBM गया, इंडियन ब्यूरो ऑफ माइंस. आई मेट डायरेक्टर्स, टेक्निकल डायरेक्टर्स. मैंने उनसे डिस्कस किया, आप जो ये ओर एक्सट्रैक्ट कर रहे हो और आपका मैंने पेपर देखा 2015 का कि गैलियम इज गोइंग टू बी लाइक दिस, बट वेयर इज द रोड मैप? एंड दे डिस्कस, सर हाँ बहुत इंटरेस्टिंग, ये तो सर हमने स्टडी किया है कि वी नीड दिस टाइप ऑफ मटेरियल. सो एक्चुअली दे हैड दिस कोलैबोरेशन प्रॉब्लम कि उन्होंने कोलैबोरेट नहीं किया. एक इंडियन ब्यूरो ऑफ माइंस को सारे और निकाले, बट वो डायरेक्टली एक्सपोर्ट हो रहा है फॉरेन, फिर वहां से सारे मटेरियल प्यूरिफाई हो रहे हैं, फिर फाइनली वी आर बाइंग बैक टू वेफर्स. सो दे डोंट नो दिस इज एक्चुअली यूज्ड, वो कभी उन्हें पता ही नहीं था. सो वी आर ऑल्सो वर्किंग विद दीज इंडियन ब्यूरो ऑफ माइंस लाइक ऑल दिस टाइप ऑफ रिसर्च लैब्स, बट फॉर दिस सर नोस पॉलिसी मेकर्स अगेन वी कैन नॉट डू एनीथिंग, बट वी हैव टू डू समथिंग. थैंक यू. हाँ
Sir, basic electronic works in hundreds of megahertz.
yes
But we are using gigahertz frequency, even terahertz.
yes
So how that high frequency has been tackled?
tackled, right? Megahertz FM 88 to 108 megahertz. Frequency, चलिए सर, एक फर्स्ट ऑफ ऑल दिस क्वेश्चन इज रिलेटेड टू, सर ने पूछा कितने ज्यादा फ्रीक्वेंसी तक हम टैकल कर सकते हैं. एक्चुअली एवरी फ्रीक्वेंसी, सभी फ्रीक्वेंसी के अपने अपने एक एप्लीकेशन है. जैसे आप फेडरल कम्युनिकेशन ऑफ कॉर्पोरेशन एफसीसी एलोकेट फ्रीक्वेंसीज, ठीक है, हम उस फ्रीक्वेंसी में डिवाइस बनाते हैं. हमें कहा गया कि लाइक आई हैव टू डेवलप सम डिवाइसेस फॉर 300 गीगाहर्ट्ज और 0.5 टेराहर्ट्ज, 500 गीगाहर्ट्ज फॉर सम एप्लीकेशन, राइट? Some medical applications or something. तो we start research, basic device research कि ये device क्या इस frequency के लिए emit कर सकता है उस particular, चलिए अगर photonics की बात करें तो wavelength की बात करते हैं, इधर बात करते हैं तो उस signal की बात करते हैं. तो जैसे जैसे हम frequency बढ़ाते हैं कर तो सकते हैं, but material is one thing, but second power. So you start from kilowatt, megawatt in the kilohertz range, right? जैसे gigahertz like watt, hundreds of watt, or even lesser. Terahertz, even milliwatt, microwatt, and all. जैसे एग्जाम्पल टेराहर्ट्ज का यूज अभी सर ने बताया, टेराहर्ट्ज ज्यादातर मेडिकल साइंस में भी स्टार्ट हो गया है. जैसे स्किन, आपकी स्किन के ऊपर कोई प्रॉब्लम है तो डॉक्टर कैन डायग्नोसिस विद द टेराहर्ट्ज सेंसर्स, बट बिकॉज देयर पेनिट्रेशन पावर इज वेरी लेस. Of course, this is initially we call it penetration is low, so we cannot use in many applications. I also went to Archaeological Survey of India. I met director there. वो ground penetration radar पे काम करते हैं, because जमीन के नीचे temples में बहुत सारी चीजें ऐसी हैं छिपी हुई. So then, unfortunately, उनके पास वो researcher नहीं है या collaborations नहीं है जिसमें they can identify कि what we can do. Just I said, sir, this is ये VNIT प्रॉब्लम, आप VNIT को दीजिए, ये प्रोजेक्ट डेवलप कर देगा. इन सिंगापुर यूनिवर्सिटीज लाइक स्टूडेंट्स आर डेवलपिंग दिस टाइप ऑफ रिक्वायरमेंट्स. जस्ट दे मेट बिकॉज इट्स लाइक समहाउ कल्चर इज देयर. आप WCL के कोई प्रॉब्लम्स हैं यहाँ पे, IBM के प्रॉब्लम्स हैं, MECL के प्रॉब्लम्स हैं, CSIR लैब्स के प्रॉब्लम है, सिर्फ और सिर्फ इंस्टीट्यूशन ही सॉल्व कर सकता है फर्स्ट लेवल पे. तो ये कल्चर है बात से. तो ये सर आपका थोड़ा मैं अलग हो गया सब्जेक्ट से, लेकिन टेराहर्ट्ज में हम डिवाइस डेवलप कर सकते हैं. उसके लिमिटेशंस बस उसके पेनिट्रेशन हो गए या पावर हैंडलिंग हो गई. सिलिकॉन इज रीचिंग इन दैट वन. जैसे IIT हैदराबाद इज वर्किंग ऑन टेराहर्ट्ज साइड नाउ, ऑल सिलिकॉन बेस्ड, बट इट्स अ फोटोनिक साइड. इलेक्ट्रॉनिक साइड लिमिटेशंस आर देयर. ओके, थैंक यू. थैंक यू.
Thank you so much, sir, for an insightful, enriching, and interactive talk. Your detailed perspective on cutting-edge semiconductor technology and India's roadmap towards technological self-reliance have certainly sparked a lot of curiosity and ideas among our students and the esteemed attendees. Thank you so much, sir. May I now invite Vice Principal of our college, Captain Professor Prashant Ambekar, to propose the formal vote of thanks.
Good evening, everyone. At the outset, I would like to congratulate all the stakeholders of Dharmapet MPDO Memorial Science College, Nagpur, for continuing the Golden Jubilee celebration by organizing the science lecture series for past 6 years. For me, it has been an honor to be a part of this wonderful event and to propose the vote of thanks. On behalf of Dharampet MP Deo Memorial Science College, Nagpur, I would like to extend my heartfelt gratitude to our esteemed guest, Dr. Kumud Ranjan ji, semiconductor scientist, NTU, Singapore, and Director Tech Data X Private Limited, Singapore, for his valuable and insightful talk on semiconductor technology, opportunities and challenges for Bharat, and for addressing all the questions from our students during the interactive session. Thank you, sir, for sparing time with us and despite your busy schedule. I would like to express sincere thanks to our Honorable Advocate Shri Ulhasji Aurangabadkar, sir, President, Dharampet Education Society, Nagpur, for his valuable guidance and for gracing the function. Thank you, sir. My sincere thanks are also due to Honorable Shri Deepakji Dudhane, sir, Vice President, Dharampet Education Society, Nagpur, for his valuable support and gracing the function. I express my sincere thanks to Honorable Shri Sureshji Dev, sir, Secretary, Dharampet Education Society, Nagpur, for his unwavering guidance and support. I wish to remain indebted to Honorable Dr. Vilasji Deshpande, sir, President, College Development Committee, Dharampet MP Deo Memorial Science College, Nagpur, and Executive Member, Dharampet Education Society, for his presence and directions. I am also thankful to Kumarji, Vinayji, and Patakji for gracing the function. I am also thankful to our respected principal, Dr. Akhilesh Peshwe, sir, for motivating and guiding us throughout this program. I would like to thank all the honorable members of the Dharampet Education Society, Nagpur, for gracing the function and support. My sincere thanks to the IQAC Coordinator Dr. Nitin Gaikwad, Vice Principal of Junior College Mrs. Vinaya Kashikar, and Supervisor Junior College Mrs. Shobha Jhalke Madam, heads and faculty members of various departments for working hard for this event. Thanks are also due to Ms. Avanti Chaple for nicely comparing the event, and Shri Atulji Moge sir and his team for the sound system and other arrangements. I am also thankful to the media personnel who are present here for coverage of this event. I am also thankful to the non-teaching staff of the Dharampet Science College for making the program arrangements and the related things. Finally, thanks to all dear students and attendees who made this event a memorable one. Thank you one and all. Jai Hind.
Thank you, sir. As we conclude today's program, let us carry with us the inspiration of today's thoughts and the resolve to contribute meaningfully to the progress of our nation. With this spirit, I now request all to raise for the recital of Pasaidan. I invite Dr. Shraddha Joshi Madam for the recital of Pasaidan. Thank you.
आता विश्वात्मके देवे येणे वाग्यज्ञे तोषावे तोषोनी मज द्यावे पसायदान हे जे खडांची व्यंकटी सांडो तया सत्कर्मी रति वाढो भूता परस्परे पडो मैत्र जीवांचे वर्षत सकळ मंडळी ईश्वर निष्ठांची मांदियाळी अनवरत भूमंडळी भेटतो भूता चला कल्पतरूंचे आरव चेतना चिंतामणींचे गाव बोलती जे अर्णव पियुषाचे चंद्रमेजे अलांछन मारतंड जेतापहीन ते सर्वाही सदा सज्जन सोय रे हो तू किंबहुना सर्वसुखी पूर्ण होनी तिन्ही लोकी भजी जो आदि पुरुखी अखंडित आणि ग्रंथोपजीवी विशेषी लोकी दृष्टा दृष्ट विजये हो आवेजी येथ म्हणे श्री विश्वेश्वरा हो हा होईल दान पसारा